Okay, so we're going to finish up our programming lesson today. And I'm going to first just briefly review the very main concepts. So first concept that we learned about in this lesson is that of a decision structure called if, else if, or elif, else. Okay? So this is where you're basically, and you need some sort of relational operators that we call their comparison operations done. And based on the comparison you're making, you're going to decide to execute certain block of statements. And if not, then some other. And if not, then some other. And if not, then some other. And you can actually build your code however it is that the logic of your problem works. And you can also have a catch-all else that happens if none of the above was applied. Well, then you can have a block of statements that executes. So one example here, this was sort of like an example that we used in class, but for two numbers that you have in your code, if x is larger than y, there's this colon that you always have to put there, then you define c to be this. Okay? This block of statements here, there's one statement. It could have been as many as you'd like. Okay, so it can be there an entire block here. And the way I recognize that those are the statements that are going to be executed if the x is larger than or equal to y in this case, is by indenting them 4 spaces. Okay, so you have to have an indent 4 here. And then whatever you write underneath will be executed in cases this is true. Now, if this is not true, then I go to the next line, okay? And I check, in this case, I check another comparison, and I look whether y divided by x is larger than 0. Okay? And again, don't forget the colon here. And then in that case, I execute something else. What I write here really depends on my problem, so it doesn't matter. As long as I'm indented by 4 spaces, so there is 4 empty spaces here, okay, then that's what's going to execute if this thing is true. And I could have continued. I could have had multiple other cases, but I don't. And I just say, well, otherwise, if none of the above was applicable, then just print, in this case, nothing happens. Okay? So I choose what to do in that last case. So this is my catch-all in case. So this is my sort of decision tree type of statement. Now we also had loops, and loops are there simply to repeat things multiple times. So here's an example, and this is sort of a quintessential example of summing up elements of an entire array. So I have imported numpy as np because that's what I need to create an array. And I created x as a simple array between 0 and 100. Okay? How many elements does this array have by default? 100. But this is 0 and 100 are now limits, right? It's between, values are between 0 and 100, and they're equally spaced, and I actually by default have 100 of them. And then, regardless of how many I request to have, if I want to sum up all of the elements, so in this case 100 times, that's not something that I'm going to type 100 times of anything, right? That's a lot of typing. So I need sort of a structure that will repeat something 100 times, and for loop is what we use. So for loop says, okay, let me create a range of numbers that go from 0 to the length of this array. Length of x is actually returning the length of the array. And I'm going to, for k in that loop, which goes 0, 1, 2, all the way to 99 in this case, okay, I'm going to simply go and I'm going to initialize my sum as a 0. And I'm going to simply go and say, okay, to that previous sum, keep adding this current element of x, okay, that I'm going through. And this is something that gets repeated 100 times, and I'm going to update my sum 100 times, and that's precisely what I need to do. This is one of the key things you need to understand for this test, okay? I might have wanted to do a product. Product would be similar. I would just initialize a product with 1, okay, and then multiply as I go along. Are there questions about any logic of this? What actually executes? How it actually works? Okay. So then part of your homework was like there's all these imaginative sums that were created, and you just simply had to write code that actually does that. Now, what is this sum and what it is that you're summing up often depends on the problem you're solving. We just came up with some artificial situations so that you get the practice of writing that code down, so when you need to apply it in your case, you know what to do. So for loop, it's the best when you actually have a problem that you know it's going to get exactly executed this many times. Okay? And then you just figure out how to create your counter. This K is a counter or an index that is going to go over all of the cases, and then you just sample something that you need. Sometimes you don't know how many times. You just have to check whether something is true. Every time you execute and you do something and you change something, and based on that changed value, you need to check whether you're still within your limits. Okay? So in this case, I wanted to divide 1 and keep dividing it by 2 until I hit a number that is less than 0.01. I don't know how many times in advance it's going to take me to do that, unless I actually go and solve the problem by hand, and that's pointless if I'm going to employ computers to do that. So in this case, I have a while loop. So while loop is that you're just checking whether something is true, but you don't necessarily know how many times you need to execute your loop to get there. So I start with x is equal to 1 here, and I say, okay, while my x is larger than or equal to 0.01, keep dividing. Okay. And the key thing here I'm printing it because I want to see what it is like, but the key problem is to update x as I go. So this basically divides x by 2, and at the same time, it updates this x with this new value. And then I go back and check, hey, is this number larger than or equal to 0.1? If yes, it's going to execute. If not, it's going to stop. Okay? So this is my while loop. And finally, we learned last time how to package our work, how to clean it up, okay? And create functions. Functions, I created them with 2 things last time. One is my kitchen, the other one is Vegas. Either way, I want to sometimes close the door and leave it either in Vegas or in the kitchen. For those of you who were not in class, when I cook, I'm pretty messy. I cook willingly, but I create quite a bit of mess in the kitchen. And when I have guests, I like to create a presentation, put it on the dining room table, and not let the guests see the mess I made in the kitchen. Okay? So function is sort of an equivalent in computing. Whatever it is that you need to solve the problem, okay? You create some arrays, you do computation, and then you have the final result. You give that result out, and all of the mess stays in the kitchen and is not shown to anybody to the outside, and is actually destroyed after you leave the function. So function takes some inputs, whatever it is that it needs to compute, then it computes. That can be quite lengthy. Okay? Everything that was created in that process remains in the function unless it's the result that I send back out. Okay? Pretty much just like what kitchen does. Also, you could say whatever happens in Vegas stays in Vegas. Okay? So either parallel you'd like. Okay? The point is that in this definition, I took 2 inputs, A and B. Okay? DEF, definition, def, defines a function with the name plus times, underscore times. I choose the name, or I give you the name, whatever it is. I can ask you to give it a certain name. And these are inputs, A and B. Okay? Colon again. Colon signifies that there is a block of statements that are now within this function. So in this function, I do something with A and B. In particular, I create S and P. It's a sum and a product in this very simple function. And then once computed, I return them. Okay. if I were to execute this function outside, so as long as I have this defined somewhere below in the code, I can execute it. And what I do is I say, hey, C and D is equal to plus times of 4 and 5. So 4 and 5 in this case is my input. Okay? This function is going to take it, it's going to create sum as 4 plus 5, which is 9. P is 4 times 5, which is 20. And it's going to return 9 and 20 and assign them to variables called C and D. So at this point of code, after the function executed, I don't know what S or P are. They only live in that function. That's what I mean that function cleans up and things stay in the kitchen or Vegas. Okay? So outside of this function, I actually don't know S and P. I return them into C, D. And if I don't return them, I don't know about them at all. They just kind of get printed on the screen and I move on and I can't use those values anymore. So when function returns me something, I also have to be ready to receive. Okay? And this CD is me ready to receive the result. And then I can work with C and D later in the code. Is that clear? It often happens in computing. There could be a process or computer that spits out the result, but there has to be another process or computer that is ready to get that result or receive it. Okay? So in communication, you have to have somebody sending information and somebody receiving that information. Otherwise, there's miscommunication. In human communication, that's true too. Okay? Just because somebody is talking at me doesn't mean that I'm listening to them. Just because I'm talking at you, half of you are not listening right now. Okay? So that's this sending and receiving. And this CD, so I might be sending something, but question is, are you receiving? Okay? And in this case, C and D are receiving the information, and then we can work with it. Okay? All right, so these are basically the base things, base parts of the programming. I didn't go into all of the details of this, but this is just a brief review of all of the key concepts that we went over. Let's apply them. So here's your assignment right now for the class. You and I will walk around helping you. So you want to create two arrays with n, I'm defining n for a reason, as 100 random numbers in range -1 to 1. Okay? So you have to recall the functions that do that and create two such arrays. And then for those arrays are defining 100 points in xy plane. And all of those points, I know that they're between -1 and 1 in both of their coordinates. Right? So they fall into this square, -1, 1 square. Now I want to say, for all of those points, go and inspect which ones actually fall inside the circle of radius 1. And those I want plotted with blue crosses. And for the ones outside, plot them as red dots. Okay? And I want to also count the number of points, and I want to call that number S, that falls outside of the circle, or inside of the circle. And print a statement saying, I don't know, let's say that it was 50 points. 50 points fall inside the circle of radius 1. So I want you to create a script that does this. You can work on a paper, you can work on in your Jupyter notebook. I suggest that you program, because then that way you will work on type. So let's do that right now, and let's work on it. And then our next assignment will be to package it into a function. If you need the slides for this, I have updated all the slides on the... It's not number 1. Everybody knows which function to use to create random numbers? So you will, oh, what is that? You will import, I can write here. You will import numpy as np, and then the function you need is np.random.rand. And you have to scale it. By itself, it's going to spit out something between 0 and 1. Okay, so you have to actually stretch it to -1 to 1, right? And you have to, if you want multiple numbers, then you have to give it input. You know precisely how many. You can yeah. No, range is from, it's 100 points. So range is from 0 to 0,100. No, because you start with the 0. So 0, 1, 2, 99, that's 100, right? 0,100.
So you get 2R.
So, but random will not, you can't specify range. So you can specify how many. But you want to scale it. So if you have this number between 0 and 1, you want to stretch it to -1, add -1 to it. Times 2 times that. One comment in terms of more generalized way. So if I know that my rand function returns number, let's gonna say it's R, and that R is in 0, 1. Okay? Whenever I want a range that is different from 0, 1, in this case it's -1, 1, but I could ask you in multiple different ways to give me something from 20 to 40 or -30 to 75 or so forth, right? So let's say that I want to map this to A, B. Okay? What am I going to multiply that number R to get to stretch these all these numbers that could be between 0 and 1 to AB? It's A plus B minus A times R. Yes? Do we see why? So if R is 0, I'm going to get A. If R is 1, I'm going to get A plus B minus A, which is B. So the smallest number I can get here, when I'm mapping numbers between 0 and 1, is A, and the largest is B. So I have mapped 0, 1 to AB. Yes? So now if I put A to be -1 and B to be 1, I'm going to get -1 plus 2 times R. So for any random number that is, I can run the rand function, and it's going to give me something between 0 and 1. This is how I'm going to scale it to whatever range I want it to be. And here I'm putting a general range. Okay. Clear? Should I go explain once again? Maybe it's clear, maybe it's not, maybe it's funny, I don't know.
So 0R, a random number generator.
So if I have any, yeah, this is a random number generator. All I know about it is it's going to give me relatively uniformly, if I'm asking for 100, relatively uniformly distributed, meaning equal number in all kinds of sub-ranges of numbers between 0 and 1. How do I map all of those numbers to something that is some different range? This is the way. But what I'm really doing here, okay, I'm looking for a linear transformation that maps 0, 1 to AB. So that linear transformation is a linear function. It's kx plus L, if you will. And when I map 0 in that linear, it should be mapped to A, and 1 should be mapped to B. Sorry if this is in the way. I need to. So this is your general way that you want to understand and remember for your exam. Hint, hint. Because I'll commonly ask you to generate me random numbers in this and this range. Okay? And we've asked you to do homework already. Yeah, homework 2. So have you figured out how to put together these arrays? So now that you have these 100 points you need, which type of loop to go through them and plot them one way or the other? For loop, because I have precisely 100, so I know how many. How do I create a range of numbers that my indices will go over? It's a range function. And that range function, if it goes between 0 and 100, I'm going to get what I need. This is the range function. Right? You can say length of that array X that you created, or you could say 100. Either way works. And then for all of those pairs, X of I and Y of I, you got to do something. You got to decide how to plot them, and you got to plot them. What is the plot function you're going to use? Plot. In which module is that plot function? Matplotlib. So you're going to import, and I'm going to change something to something that writes import matplotlib.pyplot, right? As PLT. If you have started that cheat sheet that you need for your test, the good things to put on it, you're going to be able to have a cheat sheet during the test. I told you enough time in advance. What's the complaint?
It says
import matplotlib.pyplot as PLT. So work on it a little bit for yourself. Yeah, the plotting is actually really simple. It's just that based on whether the XY is in, you have to decide whether it's inside the circle or not, right? So the points You just have to actually say PLT dot, it's scaled, axis scaled. I'm gonna give you that command. If you want it, it's oval because it's PLT dot axis scaled. I'm gonna write it in a second. So import numpy as np. Yeah. So these are my two arrays that are scaled to arrays with values in -1, 1. Now, yes, I could just say PLT plot of XY, right? And give it some blue crosses or something like that. And if I do that, points are kind of everywhere, but that's not what I want. For those points that are in a circle, I want them in blue, but otherwise outside of a circle, I want them in red, okay? So what I'm gonna do, how do I do for loop? To loop over every point so I can inspect it. I'm gonna use n because I defined n as 100, right? Colon. How do I know that the point xy is in a circle? What's true for points, such points? Within a circle of radius 1. What is a formula for circle of radius 1? Yeah, so circle itself is x squared plus y squared equals 1. Within that circle means less than or equal to 1, right? So I'm going to say if x of I squared plus y of I squared. So now I'm grabbing this ith point, right? I have 100 of them, and I'm walking through each and every one. If this is less than or equal to 1, then plot, and not now xy, but x of I, y of I. Else, plot this point as, what did I say, red circle or something like that. I missed the column. If I would find out soon enough. And I do like, sometimes you don't have to put brackets. I like kind of putting brackets because that keeps things orderly, at least in my brain. And maybe give it some space so you can read properly. Okay? Yeah. And then somebody said, yeah, this looks like an egg. You can say PLT axis scaled, and that's going to fix it. This part is for beauty. If you don't know this on the exam, that's fine. Okay? This is something that you just have to know that if you want to make things pretty, you can. Okay, so now this is a little more square-like. Cool. This is not very impressive for 100 points. Notice something. If I actually change this 100 to n everywhere, right? Then I can scale my code just by changing n. Do you see that? So I replaced 100 in all of the key places with n, and I defined n as a variable. So then just on top of the code, I can just say, well, let's make this 500. And then execute again. And this now takes a little longer to execute, but now I actually properly see this shape of a circle that I was talking about, right? You can now push your computer to 1,000 or 2,000. Maybe for 2,000 you might be waiting for a while to this to be plot. Yeah? That's the point of practice in class. And you can that's the whole point. Make your mistakes right now. So I want you now to count how many points in the code, please. Count how many points I have inside the circle. Good. So play with it a little. How do I calculate how many points do I have inside a circle? So I'm just gonna, I have this question if here, so that's where I'm gonna count. So I'm gonna just say, well, S is 0 to begin with. And then if I fall into these blue plot points, I'm just gonna say S is S plus 1. Okay. And at the end, I can just say print S points are inside the circle of radius 1. It's just reporting. So do we get this part? Mm-hmm. Okay?
Can you scroll back up?
So it's 396 out of my 500 are in there. Question? Have precisely the same text as I do. There should be a colon. Do you have brackets around this? Put brackets just in case. Okay. So we have already noticed that I can basically, if I replace all of my hundreds with n, I can easily just change n, okay? And do that. Now, assuming that this is actually a function, or this is something that I want to execute multiple times, I just did a couple of times just like right now in class, this is the ideal thing to put into a function. I don't really create, like if all I care about is how many points in the end is within that circle, and not necessarily plotting them or just plotting them for one time, I don't want to keep this x and y in memory. I want to just execute the function and clean it out and just get the information that I need from it. This is actually a way to estimate number pi, by the way. So we're going to now step towards creating a function out of it, an approximation. So if I look at s divided by n, its approximation, especially as you execute for more points, somebody execute for 5,000 and it's really kind of covered. Okay? I can estimate approximately the ratio of the area of the circle and area of the square. Do you agree with me? So what is the area of the circle? This is circle of radius 1. What is the area of it? R squared b, right? And r squared is 1. What is the area of the square? Of the square, minus 1, 1 on a side. What is the length of that side? 2 times 2 is? Thank you. We can still do that, I hope. So this is the proof without the computer help. Okay. So this is approximately the number of points that I have inside the circle divided by total of them. Yeah. So S divided by n times 4 is approximately pi. Can you check? Okay. Let's check. So approximately, I'm going to say pi approximately is equal to S divided by n times 4. And for some reason, okay, let's calculate this all over again. It doesn't want to print. Oh, I need to print it. Pi-ish. Okay, it's close to 3.14. What is the error? So the error, the way we calculate error, is this approximation. And here I actually have pi already computed. It's np.pi. This I do expect you to know that it exists in NumPy. And we can do relative error. It's divided by the So the way we calculate error is I take the approximation minus the actual value divided by that actual value. That tells me the relative error in here. Okay. So I can also print error. And my error is less than 1%, by the way. So that's pretty good. For, I think I did 500 points. As you increase the number of points, this error is going to go down. You can test that. So our final thing here is I want to package this into a function. How do I do that right from this code? Okay. I want that function to take in n, okay? And I want that function to give me approximation for pi and error back. Okay? So all I need to do, I'm going to put this code up here, is the following. I'm going to define function, and this is called Monte Carlo method. So I'm going to say Monte Carlo pi. And input for it is n. Okay. I'm going to indent all of this code by 4. And at the end of it, I'm just going to say return pi approximation and error. Now this is a function I can call below this code. So I took just the entire code I wrote, I indented it by 4, so now it's within the function block. At the beginning, I defined the function and gave it a name as well as input. So now I can execute this for 100 points, 500 points, 5,000 points, whatever it is. Everything will be executed as before. And I can actually get my pi approximation and error back.
Where's your n equal 100 and all?
It's not there. It's going to be input into the function. Okay? So now this function will execute for whatever I give it. Let's try. Maybe I made a mistake. Just give me 1 minute. So somewhere below, I can now say execute for 200. Oops, name error. Okay, I gotta execute in the same block. I didn't execute the block before. Never mind. Invalid syntax. I forgot my colon. Now the function is correctly named. Don't forget that colon. And now I'm going to execute for 200. And here it is. But I can also execute for 500 or 300. Here it is.
So you got rid of the N.
I got rid of the n. N is my now input. Okay, I didn't get rid of it. It's input. So this function will execute for whatever n I give it. That's the whole point.
So where do you set any orders on there?
I don't. I give it here. When I execute. Yeah? That's the whole point. I could set it as a default. We'll cover that next time.
How do you get a negative here?
I didn't put absolute value. I should have. Okay? So I just know that I got the smaller number. Okay? So I can clean up this error to be NP absolute. Yeah? Of the entire thing. And then it's fine.